Hello everyone. So in this pre-lecture tutorial I'm going to demonstrate how we calculate the percent composition of a compound. And what you're going to find is if you've gotten pretty good at determining the molar mass of a compound, then this particular type of problem should feel comfortable for you. So if I have this compound right here, aluminum hydroxide, if I were going to calculate its molar mass, then basically I'd have to, as I've been doing over the past week or so, I would have to count up each of the atoms that are present in the compound. So aluminum hydroxide has 1 aluminum, 3 oxygens, and 3 hydrogens. And so at this stage, basically I would have to look up the molar masses of each of these elements. And so I have aluminum, whose molar mass is 26.98 grams per mole. So 26.98 grams per mole. I have 3 oxygens, and each oxygen has a molar mass of 16 grams per mole. And each hydrogen has a molar mass of 1.008 grams per mole, so I'd also have to multiply that by 3 because there are 3 hydrogens in aluminum hydroxide. And then I would add all of this up. And so I have a calculator right here, and so I'm going to add it up myself. So 26.98 plus 3 times 16 plus 3 times 1.008. And I get a molar mass of 78.00 grams per mole. And so if I wanted to figure out the percent composition, I have to determine the percent of each element present in the compound. And the way that I do that is I take the individual molar mass for each element as it exists within the compound and then divide by the total molar mass of the compound. So for example, if I wanted to calculate the percent of aluminum, that would be 26.98 grams per mole, and I'm going to divide that by 78 grams per mole and multiply that by 100. So I'll do that myself right now on the calculator, and I get 34.59% aluminum in this compound. Then I'm going to do the same for oxygen. So oxygen contributed 3 times 16 grams per mole to the total molar mass of the compound. So for oxygen, I would take that same amount, so 3 times 16 grams per mole, and divide it by the total molar mass of the compound. And again, multiply by 100 since I'm looking to express it as a percent. And if I do that, I get 61.54% oxygen. And then lastly, to find the percentage of hydrogen, then I would do the same thing. Basically, the hydrogen contributed 3 times 1.008 to the molar mass of the compound. So I would put that same factor in the numerator here, 3 times 1.008 grams per mole, and I'm going to divide that by the total molar mass of the compound. So that's 78.00 grams per mole times 100. And so I'll calculate that out right now as well. And what I get is 3.88% hydrogen. Now, a good thing to do to make sure that your answer is reasonable is I should be able to add up the individual percentages for each of the individual elements that exist in the compound, and they should all add up to 100%. And so I'm going to go ahead and check that for myself right now. So 34.59 plus 61.54 plus 3.88. And what I end up with is 100.01%. And again, chances are this 1 in the hundredths place in this percentage is probably due to rounding error. In other words, we had to round a couple of times and actually expressing these percentages to 4 significant figures. And so This is reasonably close to 100%, and so my answer is reasonable. So work on the problems that I've put here as follow-up problems. Go ahead and use this video and this procedure as a template to sort of guide your work. And if there are any questions, by all means email, and we'll discuss this further in class. All right, have a good night.